Hello, I'm Hasindu Dahanayake. So in this video, we are going to see a fire alarm monitoring system. First, we'll see an overview diagram of the system to understand the architecture of the system much more easily. So here you can see the high-level view of the system. So mainly there is one common REST API available, which is developed using the Spring Boot technology, and so it acts as the RESTful services provider of the system. And you can see basically there are three different applications: one DB, two services which connects through it to the system. So now we will discuss about the connectivity and how they behave in a detailed manner by going through them one by one. So here, to prove that these applications can really run in a distributed manner, here I am running them as three separate projects in three different IDEs. And here, since they are separate projects, I can prove this by running them in a single IDE too. But to show that in a much more prominent manner, I'll use three different IDs to do this task. So if we move down to the web client and REST API, here we created them in a single project, but they can actually work in a distributed manner because they will connect only using the REST API, as I mentioned in the diagram. So if I give small description about the REST API, in here I follow the layered architecture to design this, because with the usage of an architecture, then we all know we can increase the cohesion level and decrease the coupling level of the application. It means the tightly coupled behavior of the application with some other classes or some other layers, because you can see here I'm going to use DTOs and entity objects to break the coupling or tightly coupled behavior between layers of the application. So I think this is not the time to discuss about that, about the layered architecture in uh, in in a detailed manner. So basically there are three REST controllers available: one for email, SMS, task and sensor, and another one for user. So excluding the email, SMS flow, all others have all the layers available, because sending emails and SMSs are doing through a third party service. There is no any DAO layer available for it. So accessing the third party services are done through the service IMPL class, because we all know the best place to access the third party services in the system is the service layer. So now if we quickly move down to the web client, it will display the sensor details on a table to use, and sensors which are exceeded the CO2 levels and smoke levels above 5 are displayed as red in the table. And also the details are going to update for every 40 seconds. So let's run these two applications. Here you can see REST API started in the port 8093, and now web client, I need to run the web client too. So it's going to start. So it's running on port 3000. So here the REST client, you can see the sensor details are available, but you can't see any refreshing because still we didn't run the sense app. So now let's move down to the sense app. So if I discuss the implementation details briefly, here for every sensor which is available in the database, here this app is going to create a separate thread. So then that thread can behave as a sensor and update its states for every 5 seconds. So my basic approach is to have some kind of a separate process to each sensor. So here, since these threads don't use the common memory area or the heap with each other, we can consider them like some kind of isolated lightweight processors which act as sensors. So if we have three sensors in the DB, then this app will actually going to create three different threads. So those threads can run like sensors, three different sensors. so they are not going to involve with each other. So in a deletion of a sensor in the DB, this application is smart enough to notify the deletion and destroy the thread which is related to that sensor. So there will be no any redundant threads running in the program too. So because of that, there won't be any memory leaks or loopholes of the memory or bottlenecks, something like that. There won't be anything like that because it's going to delete or destroy the thread. Since the time is limited to maximum of 10 minutes, I'll stop the explanation of the sense app from here. So for a second, if we run this app in the debugging mode, here you can see there will be 3 different threads available, and each thread will be named according to the sensor ID in the database. So let's run this again by quitting the debugging mode. So now if we move down to the DB, you can see it's updating for every 10 seconds. So actually, so this sense app is going to update its states for 10 seconds. And if we see the web client, it's also refreshing. So now if we move our heads to the RMI server and desktop client, so this is the RMI server, and here you can see its services are available in this package. And now if we move down to its main method, you can see it's listening to the REST API for every 15 seconds, and it's going to send an email and SMS to the users who are in the system with the aid of REST API. So please note that RMI server won't involve with those third-party services directly, because RMI server will send those SMS and emails with the aid of REST API. So as I mentioned previously, service layer of the REST API is the one who involves with those third-party services. So this is the object that it creates, which can access by the desktop client, or we can call it simply as the remote object. So now if we move down to the desktop client, in here there are 2 main interfaces available in it. One for the standard use and other one for the admin. So it's basically use the services or the methods of the remote object, and it refreshes its sensor details for every 30 seconds. And these applications are enriched with multi-threading capability, so there won't be any lag during the use interactivity. So let's run and see in action what's actually happens in these 2 applications. So if I run the RMI server like this, here you can see it started and it's listening to the REST API, and here you can see it's going to send SMSs and emails using the REST API for every 15 seconds. So here you can see my sout statement proves its behavior. So actually I will include some screenshots of the sample received mails and some kind of SMS in the end of the video. So now if we once again move down to the desktop client and run it, here you can see first standard user interface is visible, and here user can identify the activated sensors, especially using this table. So now if we move to the admin side, here first you need to validate queue. So then after that, if it is successful, then this section will be visible. So in here, addition to the standard user, admin can create, update, delete sensors using these buttons. Actually these text fields are not editable, they are non-editable fields. So if we create a new sensor like this, here you can see if we create a sensor like this, and if we click on the add button, here you can see it's indicating that the changes will be occurred after 30 seconds, because according to the scenario or the requirements, this view is only refreshing after 30 seconds. Here you can see the updated results. Okay, here you can see. So likewise you can do the other CRUD operations too. So I think that's all that I can describe to you in the given time period. Otherwise there is much more to discuss about the coding approaches and all other concepts that we followed during the system. But since the time is limited to maximum of 10 minutes, I think this is all that I can share with you. So if you have any doubts regarding the process, you can refer the source code, because in there we included some detailed comments. Or you can simply use the comment section below to ask any question. Okay, so thank you very much.